Hello, welcome back to Mrs. Torres' YouTube channel. Today we are going to be talking about exponent rules with rational exponents. Before we do that, let's just quickly review the exponent rules. So if I gave you x squared times x to the fourth, how would you simplify that? You add exponents, so you would get x to the sixth. What if I gave you x to the sixth over x to the fifth? Your rule is you subtract exponents. So that gives you x. What if I gave you x squared to the ninth? When you have a power to a power, the power rule says we multiply exponents. So you get x to the 18th. And the last one, we never want negative exponents. So if we're given x to the negative 2, remember this is really x to the negative 2 over 1. We just don't write it that way. So to make this positive, it flips to the bottom. So this is the same as 1 over x squared. And it works the same way if you have a negative in the bottom. So say I have 4 over x to the negative third. Because this x has a negative exponent, I need it to be positive. It flips to the numerator. So this would be the same as 4x to the positive third. Alright, now that we've reviewed those, let's take a look at our first example here. So I have x to the 1/4 to the 3/2 over x to the half, y, x to the 3/4. All the same rules apply. We just have to add, multiply, subtract fractions instead. And we have our calculator. So if you're not confident multiplying fractions or adding fractions, just type in your calculator. Alright, so the first thing that I'm going to do, I have a power raised to a power. So these get multiplied together. If I multiply 1/4 by 3/2, that gives me 3/8. Again, if you can't do this in your head, use your calculator. On the bottom here, I see I have an x to the half and an x to the 3/4. When I multiply numbers with the same base that have exponents, we add them. So 1/2 times 3/4 is going to give me x to the 5/4. And then there's nothing we can do with this y, so he's just going to stay where he's at. Next, I have x's in the top and the bottom. So what I'm going to do is, I know 5/4 is larger than 3/8. So that means, however many x's I have left, it's going to be in the bottom, because that's where there's more x's. So I'm going to take my bigger number, 5/4, and I'm going to subtract 3/8. Again, just do it in your calculator, and you should get 7/8. So that means I have x to the 7/8, and that y is still there. But now those are both in the bottom. So what's left on top? Well, really, this has a coefficient of 1, right? So the 1 doesn't go anywhere. It just stays up top. So that is our final answer. So it's the exact same stuff that we did with integer exponents. We just have to do it with fractions. But all the same rules apply. All right, let's look at the second one here. We've got all this stuff inside the parentheses, and then that's being raised to the 1/4. So I'm going to simplify within the parentheses first, and then I can distribute this 1/4. I could distribute this 1/4 now, but then I'd be working with a ton of fractions, so I'm going to simplify before I do that. All right, let's look at the top. We have an x squared and an x squared. If I multiply those, I will get x to the 4th. Then I have a y to the negative 3rd. I never want to deal with negative exponents, so what I'm going to do is immediately put that in the numerator. Or sorry, in the denominator. And then up top, I have a y to the 1/4. And then in the bottom, I had an x to the 1/2 and a y to the 7/4. All that to the 1/4. Alright, so now I have just an x and a y up top, that's fine. But in the bottom now, I have two y's. So I can add these together, or add these exponents, I should say. So I'll get x to the 4th, y to the 1/4, over x to the 1/2, that doesn't change. And then I need to add 3 and 1/2. Well, that's just going to be 3 1/2, right? So that is 7/2. All of that to the 1/4. Now I've got x's in the top, x's in the bottom, y's in the top, y's in the bottom. So I can simplify these. Let's look at the x's first. I have x to the 4th and x to the 1/2. So that means when I simplify it, I have more x's up top. So when I subtract, I'm going to do 4 minus 1/2, and I will get 7/2. Then I look at the y's. I have y to the 1/4, y to the 7/2. 7/2 bigger. That means when I subtract, I'll have a y in the bottom. So I'm going to do 7/2 minus 1/4, math, frac, and you get 13/4. I don't agree with something in my key. Let me figure it out quickly. So we have oh, here it is. Y to the 3rd times y to the 7/4. If I add those, I get 19/4 here. So this is 19/4. So the x's don't change. Now, if I subtract, now I would do 19/4 minus 1/4. And I get 9/2. There we go. So my mistake was here. I combined these incorrectly. We all make mistakes, right? So change this to 9/2. And all of that to the 1/4. Now that the inside is completely simplified, what I'm going to do is multiply this 1/4 on both of my exponents. So I'll get x to the 7/8, that's 7/2 times 1/4, over y to the 9/8, 9/2 times 1/4. And that is all I can do there. The key to these is just going slowly and really, really taking your time. Like, I made a little mistake there, which it's going to happen, but it just takes practice, and you got to really, really slow down. All right, let's look at number 3 here. So number 3, I've got a fraction, I've got some y's. So I'm going to simplify my variables first, and then we'll deal with this exponent on the outside. So I'm just going to leave this 16 over 9. And then we only have an x to the 2/3 on top, so I'm not going to touch that. And then I have a y on top and a y to the 7/8 in the bottom. Remember, there's really a 1 exponent on there. We just don't write it. So there's more y's up top, and I'm going to subtract that way. So 1 minus 7/8 give us 1/8, all to the 1/2. Now, when I take this fraction to the 1/2, I need to put this 1/2 on every single term in here. So we have 16 to the 1/2, x to the 2/3 times 1/2, so that would give us 2/6, which reduces to 1/3, and then y to the 1/8 times 1/2, so that's going to be y to the 1/16, all over 9 to the 1/2. The next thing that I'm going to do, I need to simplify these right here. Remember, raising something to the 1/2 is the same as taking the square root, right? Because my denominator is my index and my numerator is my exponent. So 16 to the 1/2 is just going to be 4 x to the 1/3, y to the 1/16. Whoops. Over 9 to the 1/2 is really the square root of 9, so that is 3. So that is my final answer there. So the biggest takeaway there is when you have exponents on the outside and you have coefficients, you need to make sure that you distribute that exponent to the variables as well as the coefficients. All right, that's it for today. See you later.